Today, we're going to extend our understanding of distance and midpoint and kind of apply it to something that you would see in real life, and it's perimeter and area. Now, we're specifically doing perimeter and area on a coordinate grid so that we can practice that distance formula some more. And this is going to be a topic that you should be a little bit more familiar with because perimeter and area we've been doing since forever. But I will reteach it to you in case you're like, I forgot those words. That's okay. First vocabulary word of the day is polygon. Have you ever heard the word polygon before? It's like a shape, but we're going to be more specific. A polygon is a closed figure made up of at least 3 sides, which makes sense because the very first time you can make a polygon or a shape that is closed requires 3 sides. So for example, a polygon could be like a triangle, has many sides. It could be like a rectangle. It could be a weird looking thing. It doesn't have to be perfect. So these are all polygons. Some examples of things that are not polygons would be this. Is that closed? No, it's not closed, Miss Quigley. Great. What about that? Is that a polygon? No. So if you have an open image or something like that, that is not a polygon. It has to be closed. And that's what we're going to be talking about today, is those polygons and on a coordinate grid, so we can do perimeter and area. Now we've put in the distance formula here again for you because it's going to be super important. Remember, when we're using the distance formula, we take the x1 and the y1 and the x2 and the y2 and we plug them in where they go in the formula. So you have x2 minus x1 squared plus y2 minus y1 squared. That's just there for you again so you don't have to look around for it, but we should be more familiar with this distance formula at this point. I just put it there in the notes again so we had it. Now perimeter. This is your new vocabulary word of the day. First one, perimeter. Do we know what perimeter is? Perimeter is like a fence. If you were putting up a fence around an object, meaning you were adding up all of the sides together, that is your perimeter. So it is the measurement of the distance around a figure. To find perimeter, we are going to simply add all the signs. Perimeter is measured in linear units, such as feet or meters. So when we are doing perimeter and area, you must give me a unit. A lot of times it's going to be the word units. But if it's a real world problem, you'd say like feet or meters or something like that. Yards, miles, that sort of thing. So finding perimeter could be really simple, but we're going to have to apply it to a coordinate grid. So here we go. Given the vertices, find the perimeter for each of the following polygons. Well, it's so important to put these on a coordinate grid because the coordinate grid is going to help you answer the questions. If I put these 3 coordinates on the coordinate grid, we'd have -2, 3, that's point A. Point B is at 3, -3, so that's B. And C is at -2, -3. If we close this image, what shape does it make? Don't think too hard. What is that called? A triangle. Yeah. 3 sides. Which means if we're finding the perimeter, all we will need to do is find those 3 sides. So we would say that perimeter, P for perimeter, is going to be equal to this first side length, AB, plus the second side length, BC, plus the third side length, AC. So all we need to do is figure out those 3 lengths, those 3 distances, so that we can, fill them in this formula and get a number for perimeter. So my question for you is, how would we find the distance for AB? What could we do to find it? Can we just count the number of steps to get from A to B? No, because it's a diagonal line. Diagonal lines mean that it requires that distance formula that's at the top of your paper. So for A to B, we're going to use these coordinate points here, x1, y1, and x2, y2, and use them in the distance formula. Now, why did I put them over A and B but not C? Yeah, we're wanting to find this distance A to B. So my x1, y1, and x2, y2 are A and B. So we would find this to be the square root of, open parentheses, 3 minus negative 2, close parentheses, squared, plus negative 3 minus 3, close parentheses, squared. Does everyone know where I'm getting those numbers from? Yeah, x1, y1, x2, y2. I didn't color code it this time because I would run out of colors. Can you guys put that in a calculator, please? And I'll tell you right now, you're going to get one of those numbers that's a decimal. Today, I want you to leave it rounding to the nearest tenth. So you don't have to go back and do the square root thing I keep telling you about. Just find me the number. And we're going to round it to the nearest tenth. When you rounded to the nearest tenth, we should have gotten 7.8. Is that what we got? Awesome. Okay, so now we have a value for the blue part. We know that the blue part is going to be equal to 7.8. All that's left is to find the green and the purple. The green is the distance from B to C. Now here's a hint. It looks like we're going to have to do distance formula over and over and over again. But what do you notice about B to C? It's a flat line, right? On a coordinate grid, horizontal and vertical lines are the great ones because all we have to do is count. What's the distance from B to C? It's 5. Look, I didn't even have to do the distance formula to know that B to C is 5 because it's flat. So we would say B to C is 5. What about AC? Can I count that one or do I have to use the distance formula? We can just count that one, right? How much is it? 6. So we know that AC is 6 units. I counted 6 units in between A and C because it's a vertical line. If you want to write a note to yourself, that might be a good thing. So for these two, we said if it's horizontal or vertical, Hoy and Vux, just count. That's a good note for yourself. Once we have all 3 sides, remember the goal here was to find perimeter. Perimeter is the distance around the figure, which means we just have to go back for perimeter and add those numbers up. In your calculator, please, what is 7.8 plus 5 plus 6? Did you get 18.8? I hope you did. Now, after we say 18.8, because this is a real life thing, we are measuring something, we have to say what we're measuring in. When it doesn't tell you what you're measuring in, you put the word units behind it. So 18.8 units is the perimeter of that object. Questions, comments, concerns? I have a question for you, and I've already asked this, but I want to hear from somebody else. Why did we have to use the distance formula for AB, but we didn't have to use it for BC and AC? Yes, perfect. I'm gonna say both of what you just said. Joseph said that AB is flat as diagonal, which means we have to use the distance formula. And then Kate said that BC and AC are flat or vertical, which means we can just count. So when you get a flat or a vertical line, you should do a little cheer for yourself because you don't have to do the distance formula to find it. You get the same answer. You can just count. Can we try another example? No. Okay, we're going to do it anyways. Let's plot these points, K, L, M, and N. So this is going to have 4 coordinates, 4 vertices. So we have -1, 1. Here's K. We have 4, 1. Here's L. We have 2, -2, that's M. And we have -3, -2, here's N. If I play connect the dots on this, what sort of shape does it make? Starts with a P. It is a polygon. Ends in the word gram, though. Parallelogram. Parallelograms work like rectangles for the most part. So if we were wanting to find the perimeter, we would just need to add up all of the side distances. So we're going to have KL LM, MN, and KN. Those four distances right there are going to create my perimeter. So if I write my perimeter formula, it would be perimeter is equal to KL plus LM plus MN plus KN. Or I'll do NK to go around in the order. Of those four sides, two of them should be really easy to find. Which two? MN and KL. Why would those be really, really easy to find? Because they're flat, right? That's why we want to put them on a coordinate grid always, because we're going to be able to take some shortcuts knowing that they're flat or vertical. But let's go in order. We just already know that's coming. If we found KL, how far is KL? Count for me. 5, yeah? What about LM? What do I have to do to find LM? The formula. All right, so let's set it up. For L and M, that means I'm labeling this as x1, y1, and this as x2, y2. Okay, notice that I'm ignoring K and I'm ignoring N because I'm only finding the distance between L and M. So those are the ones I label. We would have x2 minus x1 squared plus y2 minus y1 squared. Notice that I said the letters, but I wrote down the numbers because they're labeled already. Calculator time. Can y'all help me out, please? I'll give you a second to copy it down and type it in your... I almost said doodad. What are those called? Calculators. I literally just said calculators and then I lost that word. Okay, what did you get when you typed this in? 3.6. Very good. Remember, when we're doing distance for the midpoint, wow. For perimeter today and for area today, we're going to round to the nearest tenth. It might be different instructions later. Okay, great. MN is the next one we need to find. Do we have to use the formula for MN? No, we just count. How far is it? Five. Okay, great. Now we just have that last distance KN to find. And we're going to have to do the distance formula because it's diagonal. This is where it's going to get confusing for you because you're only writing in one color. Because if you notice, we need to use different letters as x1, y1. For me, if I use this as x1, y1, and this is x2, y2, I know it's a lot easier to see because I'm using two colors. For the gold side length, I want the gold letters. For you, I recommend, if you're doing this on a piece of paper, label x1, y1, x2, y2 when you need it, and then erase them. Because you're probably going to use the points over and over again. It's going to get confusing if they're labeled more than one thing. So only have one labeling thing happening at a time unless you're writing in multiple colors, like I am. Does that make sense? Okay, but if we fill this one in, what letter should, or what number should go first? It should be x2. So -1, and then we subtract what? What's labeled x1 in gold? -3. Yeah, this is why it's confusing because of the multiple colors thing. I get it. Plus, open parentheses, y2, which is 1, minus y1, which is -2, squared. Again, I get it that that's confusing because multiple things are labeled the same. So don't have it labeled twice on your paper. Erase it after you're done working with the distance formula, just in case. Or get multiple colors to write in. All right, yes, I see your hands working on your calculators. Go ahead and calculate that for me. 3.6. Awesome. Okay, if we take all of these side lengths that we found and we plug them into the perimeter formula, we would have 5 plus 3.6 plus 5 plus 3.6. If we calculate that, what is the perimeter of this parallelogram? Very good. But we're not just going to say 17.2. What are we going to put behind it? Units. For perimeter and area, you must have a unit. If it doesn't tell you we're measuring in feet, meters, miles, yards, whatever, you say the word units. Okay. Perimeter, how do we feel? We like add up the sides, right? It's only confusing when they're diagonal because you have to use that distance formula, number 17 on your formula chart. Now what about area? Do y'all remember what area is? For most objects, it's going to be length times width. And by most objects, I mean like rectangles, which are a lot of the things in the world we measure, length times width. But we're not always going to have a cute little rectangle or square. So finding area is going to require your formula chart because there are a lot of different formulas for area depending on what figure you have, what shape you have. Because area is the measurement of the space inside a figure, we will start multiplying, like when you said length times width, using the different area formulas. But you have to make sure you're using the right formula for the right shape because they're not all the same. Area is measured in square units. So we're going to say, put a little squared, the little floating 2 at the end of all of our units here. Like feet squared, units squared, that sort of stuff. Okay, number 3, already going to a practice problem, says find the areas for the polygons above. For number 1, what shape is that called again? Don't overthink it. 3 sides make a triangle. Look on your formula chart for area of a triangle, because it is not length times width. What does it say is the area for a triangle? Very good. So we're going to say area for a triangle. I'm making my subscript a little triangle so I remember what I'm finding the area of, is 1/2 base times height. That's straight off my formula chart. But in reality, what line segment is my base in this image? Do we know what base means? CB, the bottom, the flat bottom. So this is going to be, I'm going to say BC because it's the order I wrote it on the paper. But yeah, CB, they can go in any order because it's a segment. Okay, and what is the height in your image? AC. And the reason I'm writing it like this is because don't we already have a value for BC and AC in that problem? How far did we say BC was? 5. How far did we say AC was? 6. If you're like, where did they get that from? It's a great question. Here, when we did perimeter, we already found these distances. Don't do extra work. Use these distances here. Calculator time. What is 1/2 times 5 times 6? You can type 0.5 for 1/2, by the way. I like the fraction version, but I know you like decimals. One half times 5 times 6. 15. Now we're not just going to say 15 because this is area. We're going to say units squared. Do you see that I put the little square on top? If you just say units, technically you found a perimeter. Area is squared. Okay. Polygon number 2. We've said the name before. It starts with a P. What is the name of that shape? Parallelogram. On your formula chart, can you find the area of a parallelogram? Correct. They're going to have the same formulas. So the area of a parallelogram is what? BH. That is base times height. So bottom times how tall it is. In this image, what is our base? Like what segment is representing our base? MN, very good. And we already know MN, so we're good. But what is representing our height? Height needs to be a vertical direction. So do any of our line segments right now represent exactly vertical? No, but can't we count exactly vertical? So if we come up here and we say that the height, let me get a new color. What have I not used yet? we'll say that on this problem, the height is equal to this distance here. How far is that right there? If you just count, isn't it 3 little squares? So that means that our height is going to be 3. It's not a named line segment because it's not an edge of this image, but we can still count it. When we found this earlier, what is the distance of MN? 5. And then we just found the height was 3, which means my area is 15 units squared, 15 square units. No, they won't always be 15 units. Just happen to have 2 examples where they were both 15 units. Does area make sense? So area means we need our formula chart because the area formulas are all different. Perimeter is just adding up all the sides. And that's fine and dandy, but we're not just going to have cute little shapes. Occasionally, we're going to have things called composite figures or composite shapes. Composite means that you have taken 2 things and you've put it together. So in this image here, do you see how the full polygon, not a parallelogram by the way, the full polygon is made up of this top triangle and this bottom triangle? Do we see that? We're going to call that triangle 1 and triangle 2. Because a composite figure consists of 2 or more geometric shapes. So that means we can't just find one formula for composite figures. We must separate, like we did just now, it into basic shapes that we do know. That polygon ABCD is some irregular shape. It's a composite figure made up of a top triangle and a bottom triangle. So we're going to treat it like that. Now, of course, first, this asks us to find the perimeter. When we find perimeter, what is that again? When I'm asking for perimeter, what am I asking you for? Is that the insides or around it? Around it. So we just need to know all of these side lengths. We need to know side length AB, which is here. Sorry, that's not AB. AB is here. We need to know side length BC, which is here. We need to know side length CD, which is here. Sorry, I'm color coding for you. And then we'll just use AD here. We need to know those sides. Only one of those is going to be really simple to do. Which one is super simple to find the distance? I'm hearing mumblings of AB. I agree. Why is AB super easy to find the distance of? It's vertical. It's vertical or it's horizontal. Those are the easy ones. So AB is equal to 5. Phew. But now we need to find AD. AD is a diagonal, so that means we need the distance formula, diagonal distance formula. If I was going to label these, I would label it x1, y1, x2, y2. So this is 2 minus negative 4, close parentheses, squared, plus 4 minus negative 1, close parentheses, squared. I'm going a little bit fast through the distance formula. Are we okay with me doing that, or do I need to slow down? I'm following equation number 17 on my formula chart. To speed us up, I'm just going to go ahead and do the maths for us because I think you're probably okay with that. If we did this problem, we would get 7.8. For DC, we would also need to use the distance formula. This time, my coordinates are x2, y2, and x1, y1. Again, look at how confusing your labeling is already if you're not using multiple colors. I would recommend erasing what you used before so you don't get confused. That makes this -1 minus -4, close parentheses, squared, plus -5 minus -1, close parentheses, squared. This one's nice. Again, if you were to do this in your calculator, I'm trusting we can do it at this point. I'm just going to speed us through this. It is 5. The last distance we need is BC. Again, BC is a diagonal, so we're going to need to use the distance formula. So we need to label some points. I'll label this x1, y1, and x2, y2. Again, super confusing now that I have multiple labels, so I'm going to delete or erase the labels I used a second ago. For you especially, because you don't have color code, unless you switch to color coding, that would be great. This one is x2 minus x1, close parentheses, squared, plus, open parentheses, y2 minus y1, close parentheses, squared. Beep, beep, bop, we type it in a calculator. Again, I'm trusting we can do that part because you've all pretty much shown me we got that. We would also get 5 there. Now remember, the question was find perimeter. We just had to do a whole bunch of work to find these side lengths to be able to do that. Perimeter just means add up all the sides. So if I was finding the perimeter, it would be equal to AB plus AD plus DC plus BC. But we have all of those numbers. We just found them all. This would be 5 plus 7.8 plus 5 plus 5. Right? I'm adding up all of the sides. 5 plus 5 plus 5 plus 7.8 means that the perimeter is 22.8. Now, if I just answered like that, I will mark it wrong. What have I forgotten? Units. Yeah, you have to make sure you write that word behind it. Units. I'm going to be picky. Geometry is all about pickiness. The details matter in this class. Okay, amazing. We found the perimeter. We've measured around the object. When I want to find the area, this is where it really gets important that we know the two figures that we have. For area, we need to separate the composite figure into two smaller basic shapes, which is what we've done already. We have this triangle that looks like this, and we have the triangle that looks like this. I'm going to call them triangle 1 and triangle 2. Triangle 1 is made up of the points A, B, and D. Triangle 2 is made up of D, B, and C. Those are all the coordinate points around it, but I'm going to refer to them as triangle 1 and triangle 2. It says find the area of each basic shape. So first we're going to find the area of triangle 1. Triangle 1 have an area of 1/2 times base times height. Okay, looking at the image, which I know is hard to see because if you haven't to scroll, what is the base of that blue triangle? What segment? To me, it looks like this is the base, yeah? What is that segment called? What are the two letters? BD. So we want the length of BD. And then we want the height. What segment represents the height of the blue triangle? The purple, right? So we're going to multiply by also the purple, which is AB. So my formula would be 1/2. The distance of times BC times the distance 5, because that's AB. What is that distance BC? How far is it? Do we have to use the distance formula to find it, or can we just count? We can count, which means this is 6. 1/2 times 6 times 5 is 15 units squared. But that's just the area of the blue part. I also need the area of the green part. That's area of triangle 2. Area still has the formula 1/2 base times height. In this formula, what is the base? Now this is more confusing because it's like this triangle is upside down, yeah? But if we were to take it, and I can't like flip this over on the screen, but if you look at mine on my iPad, if I want that to be the base and I do this, doesn't it now look like a base? So everybody flip their paper over so you see that it is still your base. So what line segment still represents the base for the green one? Still BD, yeah. So we have to find that flat base. It may mean you're flipping your paper over. And then we need a height. Again, looking at triangle 2, are any of those parts of the triangle a height? Again, I'm going to flip mine over so you can see it. You can't really see it on a TV, I know. If this is the base, is this the height, this diagonal? Is this the height? How high is it? We can just count. How much does it take to get from, here I'll draw upside down here to up here? 1, 2, 3, 4. So my height is going to be 4. I had to just count that one. This is the benefit of putting it on a coordinate grid. So if we fill in what we know, we would do 1/2 BD. BD is still 6 times that value 4, which we found was the height. 1/2 times 6 times 4, beep, beep, bop, you put it in a calculator, is 12 units squared. So to find the total area of this composite figure, area total, you would add the first triangle plus the second triangle, which would be 15 plus 12, which is how many? Ooh, if we just say 27, it's wrong. What do we add at the end? Units squared, very good. Area is not that bad. Area of composite figures, we just need to be organized with our thoughts so we know what the two small shapes are. On a coordinate grid, take the easy road out. If it is a vertical or a horizontal line, just count. That way you don't have to do the distance formula. I'll stay zoomed in because I think I still see some people writing on this.